All right, well, let's get started. My name's Steve Evans. I almost said my name's Windows Server, which this past month has kind of felt like that. My name's Steve Evans. I'm a Microsoft MVP. I work in, I'm an IT guy, probably just like 99% of you are in here. And I've been asked to speak on Windows Server 2012. And I've had a really fun time kind of looking into, Windows Server 2012 overview. What should I talk about? And I kind of went through this big laundry list of, what's the really interesting stuff in Windows Server 2012? And I came up with this, what I thought was a really cool original concept, which was Server 2012 is the Cloud OS. And so either great minds think alike or I subconsciously stole the idea, because apparently I'm not the first person to come up with that concept. But we're going to talk about Server 2012 and what's new, what's improved, how did Server 2012 become this platform on which we can build private clouds? So the first tenet we're going to talk about is networking and the improvements made in the networking stack. Specifically, we're going to be talking about NIC teaming, the Hyper-V extensible switch, and then network virtualization. Then we're going to talk about storage. We're going to talk about SMB v3, which is not your grandfather's SMB protocol. We're going to be talking about CSV 2.0, but really we're going to talk about CSV 1.0 and how bad it was. And then we'll just mention how all that stuff got fixed in CSV 2.0. We're going to talk about the scale-out file system and how it enables application workload scenarios on file services. And then we're going to talk about storage spaces, which I hear the keynote kind of stole some of my thunder around storage spaces. So maybe one of you can come up and talk about it. And next, we're going to talk about clustering. And honestly, there's not a huge change in failover clustering in Server 2012. But there's a couple key features, one of which is cluster-aware updates and then dynamic quorum. And then obviously, if we're going to talk about the Cloud OS, we'll talk about Hyper-V, the hypervisor, and the improvements made in the hypervisor space. We'll talk about the improvements made to the VMs itself. We'll talk about live migrations and new scenarios that have been enabled. And then we'll talk about replication. And then no talk about Cloud OS would be complete without talking about management and automation. And small spoiler alert, we'll be talking about PowerShell there. If you guys have any questions, there's 2 mics up here in the front. Feel free to come up, interrupt me at any time. Otherwise, you can grab me afterwards if you have more of a one-on-one question. So let's get started. Let's talk about networking. So in Server 2012, the network stack probably has had the biggest improvement since whenever the networking stack was introduced in Windows. I mean, MS-DOS, Windows for Workgroups, I'm not exactly sure which. And so first, let's talk about NIC teaming. So how many people here have a server that has more than one NIC in it? All right, I'm just checking to see who's awake. How many people here have servers that have NICs from different vendors inside of it? Why do they do that to us? I don't get that. It's almost like hardware vendors have come up with this torture test of let's throw as many different vendors in this box as we possibly can. The NIC teaming software that comes from the vendors, obviously, for one, it's only going to work with that specific vendor. So if you're using Intel NIC teaming, you're only going to be able to team Intel NICs. Broadcom NICs will only be able, Broadcom software will only be able to team Broadcom NICs, et cetera. In Server 2012, we now have native NIC teaming. So the native NIC teaming, we can team up to 32 physical NICs. So if anyone here has a box with 32 NICs in it from 32 different vendors, if that's even physically possible, you could team all 32 NICs together into one logical NIC team. The NIC team provides PowerShell support. So there's no more of this figuring out, I'm running my hypervisors with server core. I want to do some NIC teaming, and I got to figure out how to enable that NIC teaming from the command line. Well, I guess you still have to do it from the command line, but at least it's in PowerShell, and it's easy to manage. So with NIC teaming, you lose a physical NIC, or if you have redundant switches and you lose one of your switches, your NIC team continues to operate. So what we're able to do here is separate out our physical implementation of the network from our logical implementation of the network. And you're going to see that theme over and over again. So I took a video, a screenshot of a lab environment I have where I had 4 physical NICs, 4 10 gig NICs, and I shut down the ports on these NICs one by one. And we're going to watch the traffic fail over here through this video. Now, over on the right in the dark pink, I apologize for the color schemes here. The dark pink is my extensible switch, which we're going to talk about in a second. And then the light pink and then eventually blue and then red, or red and blue, is the physical NICs. So I'm going to run it here. And we see I'm running iPerf. We got about 10 gigs of traffic going through this NIC at the moment. And there I just shut down the port, and you see it seamlessly fail over to the other NIC. I'm going to do it again here in a second. Here comes the second one. So as those ports got shut down, or as those NICs blew up on us, or as someone accidentally unplugged the wrong cable, we can watch that traffic, that 10 gig a second traffic, seamlessly fail over to the other physical NICs. Now, I don't know about you, but where I work, what I struggle with is not performance. It's not things along those lines. It's reliability. Honestly, in the room we were in when we did this demo, we all had a little group hug, because this was pretty exciting to have native NIC teaming that works this well. Think about the scenario where you've called PSS with a network problem, and they've been trying, you get into this vendor pointing issue between Microsoft and the hardware vendor, and who are you a customer of Intel's, or are you a customer of Broadcom's, or are you a customer of Dell or HP or whoever the case may be? And you end up in this scenario where often you have to pull the software, you have to pull the NIC teaming out to get PSS to help you pass an issue. It's almost like Microsoft started running a cloud, and they didn't want to deal with third-party NIC teaming software. They just said, hey, we'll just write our own. And that's what we get now with Server 2012 is native NIC teaming. So now we have our NIC team, and then on top of that, we can build our extensible switch. So in Server 2012, we have our Hyper-V extensible switch, just like we had in 2008 R2, except now it's extensible. So if I'm a firewall vendor and I want to extend some functionality to do virtual firewalls inside the hypervisor, I can do that. If I want to add some monitoring capabilities, I can do that. If I'm Cisco and I want to build my Nexus switching technology into the hypervisor, I can replace a switch, and I can put a Nexus switch inside of my hypervisor. On top of my extensible switch, I can build my vNICs. So using PowerShell, I can build out a vNIC for management. I can build another vNIC for live migrations, another one for CSV redirects, maybe one for heartbeats, maybe one for backups, whatever the case may be, whatever makes sense for your environment and your workloads. And then your VMs can plug into that extensible switch as well. And this is what we call converged fabric. So we see here we have this fabric here that's all converged into one single unit. And then on top of that, we build out, oh, I lost my mouse. Oh, there it went. On top of that, we build out the different traffic patterns we need. So in the R2 days, we would have one NIC, one physical NIC for management. We'd have another physical NIC that would do maybe live migrations. We'd have another physical NIC for heartbeats. And it didn't matter that 99% of the time, our heartbeat NIC and our management NIC was doing really nothing. But a live migration would kick off, and it was constrained to this one physical NIC. Now we have just this pool of networking resources below it, and then we just build out on top of that what we want to do. And it just sorts out which physical NIC it's going to use, which physical path it's going to use. Questions? Comments? Concerns? Personal attacks? OK, now let's talk about network virtualization. Now, you may think, your first thought may be network virtualization is a VMM feature. Network virtualization is actually a Windows Server 2012 feature. It just happens that VMM is the easy way to manage it today. So what is network virtualization? So there's a bunch of use cases that are really interesting for network virtualization. But just so we're all on the same page, let's start by thinking about Azure. So Azure has this need to host different customers that may be customers that are highly competitive. Coke Pepsi is the classic example of these two companies that would, can never leak data to the other one. But Microsoft wants to be able to host all these different customers on the same physical hardware. And that's where network virtualization comes in. Think of network virtualization as creating private networks that you can host different customers inside of. And as you move those VMs around, as those resources move from hypervisor to hypervisor, their physical implementation will change. Where they're physically sitting on the network may change, but the virtual network that's built on top of this physical network provides this continuous space. And it prevents customer orange here from talking to customer blue, except in the exact same way that anyone else could talk to a public resource from one of these customers. So let's look at this in a slightly different sense. So here on top, we have the logical implementation of network virtualization. On the bottom, we have the physical implementation. So I have my blue customer here. We got a couple machines. We got a SQL server and a web server, and those are 10.1.1 and 10.1.1.2. Down on the bottom, we have what's called the provider address space. And so in this specific example, the provider address space is 192.168. We've got a couple hypervisors here. And then in the provider address space, we have provider address spaces for each of our resources. So for the example, this SQL server here is 10.1.1.1, and it's mapped to the physical address of 1.10. Now, if this VM moved to the other hypervisor that's on a different logical subnet, on a different VLAN, then its provider address space would change. And then Orange comes along, and even though Orange has the same customer address space, it has different provider address spaces. And through the magic of networking, it routes the traffic around. It knows where these customer addresses are and is able to route that traffic to the correct place. So let's talk about some scenarios that make sense. Because does anyone here run a public cloud? One person. I expected one or two. So thank you for being my token public cloud guy. But let's think about some scenarios that might make sense for all of us. How many people have been through a merger and acquisition? Quite a few. Okay, so you take over some other company's resources. You may have conflicting IP address schemes. You may have, the company you took over may have addressing where, it was almost like they didn't know DNS existed. So you're like, oh, you can't change the IP of that server, or 52 things break. Instead of trying to rework all that stuff, you can bring it into your physical infrastructure using network virtualization, provide that customer address space without changing it, and just bring it in. So you bring it on top of your physical infrastructure, and then you work out the details later. What about a project I'm working on right now that's really interesting is I have a project with my developers where they want to be able to build development environments that cannot talk to each other. So we're working through a process right now and leveraging network virtualization where a developer can say, hey, I want an environment with these applications in it. It builds out that environment, puts it in one of these network virtualization bubbles, and it can't talk to the other one that was built just like it right next to it. Or let's say someone's working on development environment B, and they run into a problem. And they want to look into that problem, but in the meantime, development needs to continue in that environment. You could pick up that environment, snapshot it, create a new copy of it, make it development environment C, not to change the IP addressing. That's all internal to that little bubble. Any thoughts? Anyone? So real quick, let's look at a couple things around networking. I'm number 3, I believe. Yep. So here we are in Windows Server 2012. And let's look at the NIC teaming. So here we are in Windows Server 2012 Server Manager. Now, we're going to look at this in a lot more detail later. So we'll talk about it in more detail later. But here I have a host that has NIC teaming configured. So I'm going to just right-click and go to my Configure Network Teaming. And you can see how easy it is to set up network teaming here. Here I have my converged team. If I look at the properties on that, I can see that I selected these 4 physical NICs. They're all active right now. Okay? If one of these went offline, it would show as in a down state. If I go into the properties, we can see that we can set my teaming mode to switch independent or LACP, load balancing mode to address hash or Hyper-V port, and you can even configure a standby adapter, so if you didn't want to do active-active teaming. And if you're paying attention there, you notice that there were some virtual NICs there. So let's go look at those from PowerShell. So I'm going to open up a remote session to my Hyper-V host. It's called demo-host01. Did you know that when your computer is connected to a projector, it performs slower? Kid you not? I actually have a friend that tells a story about how projectors have demo gremlins. And when your computer's plugged into a projector, the demo gremlins run into your computer. And when the bulb burns out, that's because it ran out of demo gremlins. And so you have to replace the bulb so it gets new gremlins. So here I am. I'm connected to my hypervisor. We'll see here. So we're on demo-host01. And so let's do a get-net adapter. Hardest part about that is remembering how to spell adapter properly. So here's all my adapters. Let me make this a little easier to read. So we're going to sort object on name, and then let's format the table. And I just want to show you the name and the link speed. So here we see I have my converged team running at 4 gigs a second. And then I have my 4 physical NICs, conveniently named Ethernet 234. And each of those are my 1 gig a second connections. Okay? So I've been able to pull my resources together there and provide, this just static, this abstracted away network interface. And from there, I built my virtual NICs. And as you can see, each of those are 10 gigs a second, which always I love when the developer RDPs into the box and they're like, oh, I got 10 gigs a second, and they think they're really great, and then you have to break the news to them. OK, so let's move back to the slide deck here, and let's move on to storage. So in Windows Server 2012, I think massive is an appropriate word, improvements were made to the storage infrastructure. So the first one is SMB v3. So for all the things we wish SMB did before, I think we're finally to the point where, by and large, it does what we would want a file-sharing protocol to do. So first, let's just talk about application workload-specific stuff. So one of the things that SMB v3 enables is the ability to do application workloads over SMB. So this means Hyper-V, storing Hyper-V VMs on an SMB file share, or your SQL databases on an SMB file share are two of the really common examples. So two specific features for application workloads is SMB direct, so that if you have like InfiniBand, you can do memory-to-memory transfers. It takes a lot of load off of your processing host. And then VSS for SMB file shares. So imagine if I'm running SQL on, I have my databases stored on a file share. And now it's time for SQL to take a backup. Well, traditionally, the way it works is SQL, the backup agent comes in and tells SQL, hey, I'm going to do a backup. The SQL VSS agent goes and tells the host, hey, I'm going to do a backup, and so on down the chain until it gets to the disk and it says, hey, let's QS the disk, take the snapshot, backup runs. Well, if I'm storing my MDFs and LDFs on an SMB file share, pre-V3, we couldn't take a VSS. We couldn't say, go do a snapshot over there. So with SMB v3, we now have VSS. You can now initiate a VSS snapshot on an SMB file share. For our information workers, which means your laptop, your Windows 8 laptop, if you have it, let's say you go to Europe, and you're trying to connect to a file server back here in the States, you know how the experience right now on a Windows 7 laptop is really bad as you traverse the directory tree? SMB v3 has something called direct releasing. So it makes the experience of a high latency connection much more palatable. So for example, if you're at a conference at a large hotel in Vegas, and you have a poor internet connection, and you're trying to look at something on a file share, I guess that's not funny. It's because it's a little too painful today. And then lastly, the features that apply to both of them. So the first one is transparent failover. So in SMB v2, or v22, if I'm connected to a file share, and that node, that file share fails over to a different node in a cluster, so it goes offline for a bit, the SMB protocol does not handle that well. So if I have an application using SMB to transfer data, the application is going to find out that share went away for a period of time. Transparent failover allows SMB to abstract that away from the applications. So if my Hyper-V server is pointed to a share that is transparent failover enabled, when that failover happens, when it goes away for a period of time, we'll see if you watch the transfer speed, we'd see it dip off for a bit. But it's not going to tell the application, hey, something's horribly wrong. It's going to handle that scenario much better. Multi-channel. If I'm trying to transfer files between this server and this server, and I have multiple physical paths, it's going to use those multiple physical paths. Now, can anyone tell me how you enable multi-channel? I'm sorry? PowerShell would be a good guess. The way you enable it is you just use it. It just works. So you don't have to configure it. You don't have to say, hey, I want to do this transfer with these two specific NICs. It just figures it out for you. It takes the heavy lifting of, hey, can I do multi-channel and not away from you? You can disable it if you want via PowerShell. But it's just enabled out of the box. If I'm connecting to a 2008 R2, if I have a Windows 8 client connecting to 2008 R2 file server, and I did have multiple physical paths, it just wouldn't use them because the receiving side wouldn't, or the server side wouldn't be able to utilize it. SMB encryption. So now we can encrypt data on the fly. ODX. I think ODX has the potential to be really, really big deal. So ODX is something that gets enabled on your SAN. And the scenario it enables is let's say I'm on my Windows 8 laptop, and I want to copy this 5 gig ISO from file server A to file server B. If those two file servers are connected to the same backend storage, if they're connected to the same SAN, and that SAN is ODX enabled, instead of my Windows 8 client, instead of that 5 gig ISO touching the network, it will just happen internally to the SAN. Okay? So those large file transfer functionalities no longer will have an impact on your SAN. And the SAN vendor, if the SAN vendor supports it, it can even enable that scenario from SAN to SAN. It will transfer the data between SANs or just internally to the SAN. So really powerful. Think about it from I'm going to copy this large amount of data over here because I want a backup copy of it. Lots of scenarios. Arguably, I would say SMB v3 is the biggest feature in Windows Server 2012. When you look at all the other features, when you look at all the other things that are enabled, many of them point back to SMB v3. Clustered shared volumes. Probably because of the projectors right now, you can't see. But if you come up later, you'll see all this gray hair is directly related to cluster shared volumes v1. Really, the story here, we're going to talk about cluster shared volumes, but really we're going to talk about the old cluster shared volumes and how painful it could be. So here's the scenario. Cluster shared volumes was invented to support live migrations in Hyper-V in 2008 R2. So clustered shared volumes allows multiple nodes of a cluster to access the same LUN at the same time. Under normal working conditions, it works just fine. Now, CSV v1 is only enabled for Hyper-V workloads, and CSV, and still to this day, has the one downside of only the node that owns that CSV can perform meta operations. But in normal operations, it was fine. It's when, I don't know, whenever, say, you do a backup, that things get bad. Now, to be fair, there are certain backup vendors that back up Hyper-V in the proper way, and it only does this scenario for a short period of time. But 99% of, well, from my perspective, 99% of the solutions out there, just create this kind of havoc in the CSV world. So backup agent comes in, tells Node A, hey, I want to back up all your VMs. Okay, seems reasonable. So Node A says, okay, I own the CSV. I have to own the CSV. Because of some limitations in VSS in 2008 R2, it has to own the CSV, and it has to put the CSV what's called in a mode called redirect mode, which means it is the only node that can perform a read or write operation to the disk. Did you catch that? It's the only node that could read or write from the LUN. All other traffic would have to go through this process. The VM on node B has the audacity to want to read or write something from its disk. Its node has to go over to node A and say, could you please read this, my guest VHD for me? It goes and reads the data from the VHD, returns it to the node that the original VM was on, and then the VM has no idea this has been going on this whole time. Says, finally I got my data. I've seen situations where the network congestion is so bad that this process takes so long that the VM finally decides that its C drive must have disappeared, and it blue screens. There's nothing better than 20 VMs on a host just falling over in the middle of the night because you thought you were going to take a backup. Anyone here trying to do SQL Server mirroring on top of a Hyper-V cluster? He timidly raised his hand on that one. The thing the latency, things like SQL mirroring are so sensitive to disk latency that the CSV redirect process will cause just the mirror to fail back and forth all night long while the backup's taking place. I/O, even if it doesn't get that bad, I/O, you just have really latent I/O. So what did Server 2012 do to fix this? Server 2012 introduced something called the VSS requester service. And what this does is it means we're in redirect mode. It's much less likely we're going to be in redirect mode. The VSS requester service solves this backup redirect issue we were just talking about for every backup vendor out there. So basically, the way it works is when the backup agent comes in and says, hey, I want to do a backup, this VSS requester service coordinates VSS snapshots along all the VMs, make sure everyone's QS, the snapshot takes place, backup happens, redirect mode doesn't happen. But let's say we do end up in redirect mode. There are some scenarios where we can still end up in redirect mode. Oh, I'm sorry. I need to read file from my disk, reads the data, just like you would expect. But you can end up in redirect mode still. I think one of the scenarios, other than just something goes horribly wrong, although this example is something goes horribly wrong. If you have a node, let's say cluster node B here, just loses connectivity to storage. Let's say it's iSCSI connectivity. For whatever reason, it loses iSCSI connectivity to the SAN. So it can go into redirect mode for that. It will go over your converged fabric, ask the owner of the CSV to read the data for you, and it will return the data back. Largely due to the improvements made in SMB v3 around performance. Think SMB v3, they're allowing you to run SQL Server over SMB. Think about the performance improvements they had to make for the SQL Server team to allow an MDF to be run over that protocol. Largely because of the improvements made to SMB v3, you can get, if you have the bandwidth available, you can get up to 98% of the performance you did in direct I/O mode. Pretty impressive. Yes, does it put a toll on your CSV owner? Sure. Is it the scenario you want? No. But compared to just losing the node, it may be much more preferable. So as long as we're talking about CSV and application workloads, in Windows Server 2012, there is now a new scenario where CSVs can be used. And that is for the scale-out file services. So in 2008 R2, it was only for Hyper-V. Now it's for Hyper-V and the scale-out file services. What the scale-out file services allow allows multiple nodes in a cluster to serve up the same SMB share for application workload scenarios. So we still have that downside of the meta operations having to go through the owner. So we don't want to do this for the place your users store their Excel files. But if we're talking about our SQL servers or Hyper-V servers, it could be a really, this is the scenario where it makes a lot of sense to use scale-out file services. So the cluster group contains a distributed server name and a scale-out file server. The distributed server name, you probably in your mind just mapped it to the clustered computer name that you're used to. It's a little bit different because it doesn't have, there's no clustered IP address. The way it works is in DNS, every single node. So let's say my distributed server name is scale out. We lack creativity, so we're just going to call it scale out. The DNS record, if I looked up scale out, it's going to have an A or a quad A record for every single node in my cluster. So if I have a 6-node cluster, I'm going to get 6 A records back. The client tries to connect to the first IP. Then after 1 second, it tries to connect to the next 7. Okay? So that first record is handed out randomly to distribute the load around between all the nodes. And then if it fails to connect to that one, if it's offline for some reason, it will just try the next 7 until it finally connects to one. And this scales linearly. I give up. So if I have one node, let's say I have one node can push 100 IOPS. 2 nodes can push 200 IOPS. 3 can push, well, maybe 299. 4 can, you get the idea. 4 can do 398. And storage spaces. Now, this is the slide I did not expect to have in my slide deck. So when you speak at a conference like this, they call it a tech review, a tech check, something like that, a few weeks ahead of time. And I was talking through with someone at Microsoft about what I was going to cover. And we were talking about storage, and I had everything else in my storage section. He said, oh, you forgot storage spaces. I said, oh, yeah, storage spaces is cute. But, I mean, I didn't really see it as, I'm thinking, this is MMS, the System Center crowd. This isn't a small business crowd. And to me, I always thought of storage spaces as this thing that little companies use that don't have a SAN. And he said, yeah, no, that's fair. It's mostly used by small companies like Azure, for example. So I said, OK, I'll go take a second look at it. So I went and checked it out. And the reality is today I think it is just it's primarily targeted towards small business. But I think if you add a little ingenuity to it, if you think about it a little bit, you can see where potentially this will replace the SAN in 5 years from now or 10 years from now, where we're just going to take commodity disk and we're going to stop paying for large, expensive SANs. The way it works today is I create a storage pool. A storage pool is a bunch of commodity disks, any size, any type, any speed, just doesn't matter. I just take a bunch of disks and just pull them together. If anyone here ever used Windows Home Server some version before the latest one, it was a very similar concept, where you just plug disks into it and it just figures out how to use them. Then on top of my storage pool, I create virtual disks. And that virtual disks I can configure in a few different ways. The first is simple mode, which simply means if I have one block of data, store that one block somewhere in my storage pool. Mirroring, two-way mirroring, is if I have a block of data, store that block on 2 different physical disks. And if I do mirroring 3-way, it's 3 different physical disks. And then parity is, think of it as very similar to RAID 5, where it has the parity and the checksum and all that kind of stuff. So let's look at some of this stuff. So here I am back on my demo system. I'm going to go back to Server Manager. Let me clean up here a little bit. I'm going to go down here to File and Storage Services. Actually, first, I'm going to show you scale-out file services. So here I have a 2-node cluster set up. And you can see I have a cluster group here called demo-scale-out. And you can see all I have is the distributed server name and the scale-out file server. And then it creates shares in the CSV space. So I created one here for SQL. Okay? If I go and do an NS lookup on that name, which is demo-scale-out, it's going to return the 2 IP addresses for my 2 nodes. So you can see there's my 2 nodes, and then there's one of the nodes, and the other one's 222. Okay? So the client that goes to connect to it is going to randomly, it's going to pick one based off of the round-robin assignment and just figure it out. So the way you set this up is you go to configure a new cluster group in your cluster. You select file server like you've always done. It goes and checks that file services is available on all the nodes. And then the first question it asks you now is, should I use a file server for general use, or should I use a scale-out file server for application data? And here's the key. Where is it? File server for general use. For files for server applications that open and close files frequently. So that's the key. If you have an application that's constantly opening and closing files, scale out file service is not for you. You want to go with file server for general use, or traditional file server. If I select file server for general use, the first question it asks is, what is your name and IP address, right? Whereas if I choose scale out for file server for application data, all it asks is for a name. Because it doesn't need a clustered IP. It's going to use all the IPs that the nodes already have for their management NICs. Moving over to storage spaces. So here I have a storage pool. So I have a computer, a server here called demo-san that has 10 disks in it that have been unassigned so far. So I'm going to create a new storage pool. I'm just going to call it, I'm going to be really creative, I'm going to call it pool 2. And here you can see I got my 10 disks. I can set any number of them to hot spares if I want. And here it's going to create my storage pool. Now, one thing I forgot to tell you about storage pools is, so this is a storage pool on a single box. If I have a SAS enclosure and I can plug it into two physical machines, I can create a clustered storage pool and use that storage pool as part of clustered applications. So I think the branch office scenario is really interesting there, where maybe you have a branch office with a Hyper-V server running a few VMs. Well, now you can put two physical servers over there, an external SAS enclosure that's relatively inexpensive, and all of a sudden you've got high availability, for a fraction of the price in your branch offices. So I've created my storage pool, and now I'm going to create my virtual disk on top of that. So here I'm going to create new virtual disks. I'm just going to call it vdisk. And you can see we have simple mirror or parity. And when you select mirror, it asks, do you want a 2- or 3-way mirror? And then thin or fixed provisioned. So we'll just do thin. We'll create a 1 gig virtual disk, and away we go. And now we can use this. We can assign it as an iSCSI target. So we can serve it up via iSCSI. We can create an SMB share on top of it. Whatever we want to do with it from this point. All right? Back to 1. Okay, next up, clustering. Now, I mean, honestly, who here thinks that Windows Server 2008 R2 clustering really has problems, like really needs something to be improved? Probably no one, right? I mean, it's a pretty solid clustering technology. I mean, it blows 2003 away. And the improvements that were made to clustering are pretty, maybe not significant, but if you're going to do cloud computing, I would say pretty important. So let's talk about cluster-aware updating. So cluster-aware updating, many of you may have already done this manually or with PowerShell or maybe via config manager or a lot of different scenarios. But now it's just baked into the box so you can focus on higher level work. The way it works is you configure cluster-aware updating, and either on schedule or based on demand, it will take a node, it will put it in maintenance mode, so all of the resources on it will move off of it. Now here my slide deck shows Hyper-V VMs, but it could be file servers, it could be SQL. It really doesn't matter what it is. You're going to put it in maintenance mode. Any clustered resources on it will get moved off of that node. Then it patches that node. When that node comes back up and is online, it rinses and repeats. It goes to the next node, puts it in maintenance mode, the resources move off of it, and then it patches the next box, and it continues. Okay? And there's a lot of different cool things you can do here. You can say, I want this. You can do it, on a schedule. So you can say every Saturday at 3 a.m. I want to patch my hypervisors if there's patches available. You can do the standard WSUS patches, or you can point it to a folder with hotfixes in it. So kind of that pain of, oh, there's this Hyper-V hotfix I want to deploy, or this clustering hotfix I want to deploy, and I don't really have a great way to get it out there. It's not in WSUS. you can solve that scenario. You can require that all nodes are online before the patching process starts, which probably makes sense. If I have a 6-node cluster and one of them is offline for some reason, I might not want to start a maintenance operation. So a lot of interesting things you can do there. How many people are waiting for that 3rd node to get patched? Like, how many people have OCD is so bad that this is going to drive them nuts? And I'll probably get a bad comment. Yeah, I apologize. But those were really hard slides to do. You have no idea. The guy in the back appreciates it. All right, next let's talk about quorum. So Server 2008 introduced well, they didn't introduce the concept of quorum, but they moved away from the concept of I'm going to have a quorum disk. And that quorum disk is I have that disk or my cluster doesn't work. So now we just need a majority of the votes. We just need more than 50%. So here I have a 5-node cluster, and I need 3 to maintain quorum. The reason quorum is important is you never want 2 different sets of machines thinking they're in charge. It's kind of like raising kids. You never want two different sets of machines raising kids, and one of them goes off on their own and is trying to run, let's say, SQL, when these set of machines over here are happily running SQL already. So let's talk about the scenario where I got 2 nodes that split off from the cluster for some reason. Let's say there's some type of network disruption. For whatever reason, they can talk to each other, but they can't talk to the rest of the rest of the cluster. Well, the guys on the right, they have 2 out of 5 votes. They do not have majority. So they cannot maintain quorum. They're going to go offline. Excuse me. But the problem we have here is if we lose another node, then we've lost the cluster. Now we only have 2 out of the 5 on the left side here. We don't have quorum anywhere, and so all of our cluster resources are going to go offline. It's a really painful scenario. It can also just happen we just start losing nodes for whatever reason. Patching is a common one. We get a little over-aggressive in patching. All of a sudden, we lose all the cluster services running on top of it. We lose our cluster. Server 2012 introduces the concept of dynamic quorum. Dynamic quorum is enabled by default. You can turn it off if you want. I haven't really thought of a great scenario of why you would, although I'm sure there is one. But the way dynamic quorum works is, so right here we start with 5 votes, and we lose 1. So now we have 4 votes. We need 3 to maintain quorum. If I lose another one, we go down to 3 votes. I need 2 to maintain quorum. Right here, we got 2 votes left. We need 1 to maintain quorum. Without dynamic quorum, I would have lost my cluster right now. I would only have 2 out of the 5 votes. But because dynamic quorum is reducing votes as nodes go offline, planned or unplanned, we're able to maintain quorum with only 2 nodes up. We lose the next one. We got 1 vote. We need 1 to maintain quorum. And then anyone know what happens if you lose the last one? Yeah, nothing's that good, right? Although that would be cool. I would be impressed by that feature. So it really protects you from these scenarios where you think, OK, I'm going to build a 12-node Hyper-V cluster. And then, I'm less likely to lose quorum. The reality is on a 12, let's use 11 to make the math a little easier. On an 11-node cluster, you have to have 6 nodes up. So you can lose quorum with 5 nodes still up and running, 5 perfectly healthy nodes. So it kind of protects you from those kind of doomsday scenarios. There are a couple of requirements. The first is that you have to reach quorum first. So if you have all your nodes offline, you can't just turn the first one on and all of a sudden dynamic quorum kicks in. You have to reach a state of quorum, and then dynamic quorum will kick in. And the second is you have to have sequential failures of nodes. So that first scenario where I had the 2 nodes split off all at once, dynamic quorum wouldn't be able to help us in that scenario. But the scenario where we keep losing nodes, it will decrement by 1. So let's just look at those 2 features. So back over to Failover Cluster Manager. To enable it, we just, on the cluster itself, we go under More Actions, and we go to Cluster Aware Updating. Now, I've already configured it here, but basically what you do is it needs a network resource, a network computer name, and then a policy to work with. So I'm going to configure Cluster Updating. And as you can see, it's already enabled. It's already set up, so it's asking me if I want to enable self-updating, disable it, or just remove it completely. So I'm going to keep it enabled. And so I can determine the schedule I want this to run on. So maybe Saturday mornings at 2 a.m. is the right time for you. Maybe it's the third, in this case, the third Tuesday at 3 a.m. Whatever works for you, you can kind of work with that there. Or, back on that previous option, I just disable self-updating mode. And then I just come in and I manually or via some process come in and say, I want to apply updates to this cluster. Okay? Real quick. In here you can see all the fancy things you can do. So I've required all nodes are online before it starts this process. Right now, you can do pre or post update scripts. Right now it's using the Windows Update plugin, but you can use the hotfix plugin and point it to a directory with hotfixes in it. All kinds of really cool stuff. Now you might say like, oh, I did that in PowerShell last year. Yeah, that's cool. I mean, it's not rocket science, but it's something now you don't have to do at the next company you go and work for. And let's look at dynamic quorum real quick, although I got to be honest, it's not that interesting from a configuration standpoint. So you configure quorum settings. So by default, it just says use the typical settings. So this means if there's even number of nodes, it's going to select a quorum disk. If there's an odd number of nodes, it won't select a quorum disk. It's just going to do the obvious choices. But if you've got a specific use case you want to enable, you can go in and do something different. So I'm going to do advanced quorum. And so that's how you'd come in here and you could uncheck this box to not allow customer dynamically manage votes. Okay? Surely someone has a question. I got to be honest, my feelings are a little hurt. All right, so what's up next? Hyper-V. So Hyper-V v3. Who here's heard that Microsoft always nails the third version of a product? Yeah, well, here we are, version 3 of Hyper-V. Who here runs Hyper-V for real, like in a production scenario? And this is probably as good as it gets, right, as far as this is the crowd that is most likely to run Hyper-V. And it was 20, 30% of the room. 2008 R2 was great for certain scenarios, but when you tried to push it to kind of the upper reaches of scalability and manageability and all that, it had some rough edges. 2012 is really a whole different animal. It really just knocked it out of the park, in my opinion, as far as a hypervisor goes. So they made a bunch of improvements. You can now, in 2008 R2, you could only have 1 terabyte of memory on a physical machine, and now you can have 4. And all I could ask myself was, there's machines with 1 terabyte of memory in them? So I took this chart that, I'll be honest, I stole from someone, from a tech ed slide deck. And I narrowed it. These are the 3 that matter. Okay? So in 2008 R2, you could have a VM with 4 virtual processors. Now you can have 64. Probably not going to have a VM with 64 processors. Maybe, but I mean, that's kind of the edge case. But I can't imagine a lot of scenarios where you want to have 8. So it kind of just makes it so it gets into that number where you don't have to think about it. And that's really where you want to be, where you don't have to question how many virtual processors is it capable of. Same with memory. Again, I've never seen a physical machine with a terabyte of memory. I'm sure they exist. But I have seen scenarios where I want to assign a virtual machine more than 64 gigs of memory. And now I don't have to think about it. Virtual disk, same thing. 2 terabytes, that's a big VHD. But let's say I'm hosting a file server. I can see scenarios where I would have a 2 terabyte VHD. Clustering is another one that cracks me up. You can now have a 64 node failover cluster. Does anyone here run more than 16 nodes in a failover cluster? Yeah, OK, that's what I thought. The other big feature around VHDXs is live VHDX merging. So in 2008 R2, you delete a snapshot, and that snapshot gets merged together the next time that VM's offline. So the performance implications of having a snapshot remain until you power that VM off long enough for it to merge that snapshot back in. Or you have a process that goes through and deletes snapshots across 10 VMs. Your next maintenance window, all those VMs happen to be offline, all of a sudden you've got 20, 30, 40 virtual machines merging their VHDs, and all of a sudden you got this massive SAN bottleneck, the I/O bottleneck, I mean. So that's kind of a big deal. Live migrations. So first of all, we have live migrations. We've had it since 2008 R2. That's when we take a VM and we move it from one node to another in a failover cluster. So I have hardware that has a 2008 R2 cluster inside of it and a 2012 cluster inside of it. It's the exact same configuration, exact same hardware specs and everything, except different OSs. Okay? On my 2008 R2 cluster, I took a VM, gave it 64 gigs of memory, because that was the maximum, and I used a tool called consume.exe from the, believe it or not, the Windows Server 2003 resource kit to consume all that memory. A live migration, what it has to do is copy the working memory set from one machine to another. So you want to make sure you're using all that memory if you really want to test live migration performance. It took me 11 and a half minutes or so to live migrate that VM, and that was on a 10 gig live migration network. Anyone want to take a stab at how long it took on the 2012 cluster? And don't say like 5 seconds, because that just ruins it for everyone. 35 seconds? Oh, forget it. 65 seconds. He said 35 seconds. Like, that's reasonable. 65 seconds. So 11 times faster is roughly. So if I have a cluster that has, say, 100 VMs running on it, the concept of live migrating those things all around just got 11 times faster. The next scenario they enabled, this is a new scenario they've enabled, is live storage migrations. So I can have a running VM, and I can move it from one physical location to another physical location while the VM's running. Zero downtime. So if you need to move, let's say you've got a CSV and you want to move some of them to another CSV for some reason, you can do that with zero downtime today. And if your SAN is ODX capable, it will just happen on the SAN. It won't even touch the network stack. So that's a pretty cool scenario. And then lastly, the shared nothing migration, which is kind of a combination of the two, which is picking up the VM and the storage and moving it over to another physical location, running on a different VM on a different storage space. Okay? Now, this is not HA. Shared nothing migration is not HA. This takes time. If I have a 100 gig VHD, it's going to take me more than a few seconds to copy that over. Okay? I'm not going to get into the let's guess how long it takes game, because someone will underguess on me. So it's not HA. This is HA. So in Server 2012, we now have Hyper-V VM replication out of the box, nothing special, no special license, no hardware required. Well, hardware is required. No special hardware is required. VM replication that just works. What we do is, if we have a Hyper-V VM over on the left here, and we want it to run over on the right, or be replicated over the right, we go through the setup wizard. It makes an initial copy of that VHDX. Now, this can either be online or offline, so I can send it over the wire, or I can put it on external media and FedEx it. And then have a non-running VM on my destination. And then as changes, whoops. Oh, you missed my awesome animation. As changes happen, those changes just seamlessly, asynchronously replicate over to the destination. Okay? If anything goes wrong on the source, or if I plan a failover, it will inject, if I've configured IP configuration on that destination side, it will inject those settings and then power on the VM. So think about, let's say I have a data center with my Hyper-V clusters, and then I have a DR site where I'm going to replicate key VMs to. Different IP addressing scheme, different layer 2 networks. I can configure Hyper-V to just put the right IP settings in there when that VM gets powered up on the other side. I don't have to do that during the emergency. I can plan that in advance. The replica VM's powered on. and then it starts asynchronously replicating the changes back to the source if it's available. So this solution, it's storage agnostic. It's OS and application agnostic. So I can have a Hyper-V cluster on one side that is running on very expensive SAN, and on the other side, I've got my workstation from last year that I'm no longer using with a bunch of terabyte disks thrown into it. It's not going to perform well, but hey, I've got the VMs at least. And to clarify, when I say it's OS and application agnostic, the hypervisor has to be Windows Server 2012. The VM, it could be Windows XP, it could be Windows Millennium, it could be Linux. It just doesn't matter what it is. It could be a SQL server. Doesn't matter what it is. All it's doing is replicating changes to the VHDX file. Yeah, unlimited replication. There is no limit to how many VMs you can replicate. The only limit comes down to how much data can you replicate over your network. And it's geo-independent. So I could have my primary site here in the US and be replicating to my QA partner in India, whatever makes sense for you. Yeah. By the way, I have a copy of Windows 8 for you. He asked the first question. I mean, come on. I'm sorry? Does it leverage ODX? I don't believe so. And the reason I don't believe so, don't quote me on this. If you come and find me in the vendor, not the vendor, the like Ask the Experts area tomorrow, I'll figure it out for you. The reason I don't believe so is it doesn't use SMB for the transfer. It's going over port 80 or port 443. And realistically, I mean, the scenarios we're talking about here are, you're probably not going to replicate from this side of the data center to that side of the data center. You're probably going to replicate from this data center to that data center, which means ODX doesn't come into play anyways. You're not going to do an ODX transfer between SANs at different sites, realistically. Thanks for the question, though. I really appreciate that. Just saying, if you want to get on my good side. The cost. So what is the cost? All right, you got to license a destination. You need to provide storage on the destination. You got to provide bandwidth. Oh, all of a sudden we got more questions. I only got one copy, though, so. So the question is, what's the latency? So the goal is to keep it within 5 minutes, so that if the proverbial asteroid comes and hits your data center, you haven't lost more than 5 minutes worth of transactions. So obviously, if you are the New York Stock Exchange, this solution does not work for you. But for 99% of us, all you lose is 5 minutes. It's in the destination. Now, let's say your WAN link is severed for some period of time. It will, obviously, it's not going to be able to replicate while that WAN link is severed, but it will catch up once it's available again. So for example, I've got hypervisors running on my laptop here. Those hypervisors are rarely, they're always going up and down. It just figures it out when they come back up. Yeah. I'm sorry? Yes, I'm going to do a demo here in just a second. Oh, yeah, that's a fair point. So to do the injection, you have to have integration services. Yeah. Thank you. That was a very polite way of saying I was wrong. Yes?
I have a question on the cluster side.
Yeah.
So in 2008, R2, you could not do DNS clustering names. That is true in 2012, right?
In 2008, you could not do DNS.
I want to have a DNS name for the file share resource, and it's not supported unless somebody can show me the tricks.
You mean like a DNS alias, like a CNAME?
Alias, yes, thank you.
I'm not sure. So let me clarify. When I said I like questions I can answer. So if we could stick to those types of questions, I would appreciate it. Thank you. Were there any questions real quick? Yeah. So the way it works is essentially it takes a snapshot. It takes a VM snapshot and then replicates that snapshot. So you're right. If you run a defrag, it's going to move a bunch of blocks around, and it's going to have more. There's going to be more changes of the VHDX, so more to replicate. A lot of the times, considering that we have a VM running on top of a SAN, a lot of the times defragging doesn't really make sense. So ideally, you move away from those scenarios where you're changing a bunch of. If you're doing replication, you want to stay away from scenarios where you're changing a bunch of stuff unnecessarily. Yeah. Was there another question behind, or was I just being hopeful? OK. So let's look at these features real quick. Back over to my demo machine. OK, so here I have. I'm going to pull up Hyper-V Manager. So first, we're just going to go into Hyper-V settings, and I'm just going to show you that here I have my live migrations. Oh, one thing I forgot to mention about live migrations. So currently, in a cluster, you can only have one live migration at a time, which always blows me away. You have a 6-node cluster. You've got these two over here participating in live migration, and these two over here refuse to do a live migration. In Server 2012, you can have an unlimited number of live migrations happening simultaneously. By default, it's configured to 2. But I tried. I started putting really big numbers in, and there is a limit to how many digits it will support. But it was like 10 digits or something like that. So probably more than you need to worry about. And then you can configure which NICs or which networks are used for live migrations. So if you have a live migration NIC, you want to have live migrations happen on a specific network, you can control that. And then same thing for storage migrations. So again, it's limited to 2 by default. That's just to, you don't want all your VMs to perform horribly and fall over because you're moving some storage around. So it controls how many by default. But you can, test on your hardware. If you've got a SAN with a bunch of SSDs in it, set it to 4 or 6 or 8, whatever the case may be. So let's look at, here I have this Windows XP machine that is Hyper-V, set up to do a Hyper-V replication. So I can right-click this guy, and I can view the replication health. So I can see its current state's a little behind. It's in a warning state. You can see what its replication, how many successful replication cycles there have been, what time the last one was successful, et cetera. Again, these are hypervisors running on my laptop. It's incredible that I can even do this. So let's not get too down on Hyper-V replication here. But you can view the current health of it. You can do a planned failover. So this will shut down. So you have to shut down your source VM, do your planned failover. It will replicate over the last changes, and then power on your destination VM. It will power up. If I go into my settings, on the network card, when it becomes replication enabled, you get this failover TCP/IP setting. So you can come in here and configure, what do I want the IP address to be when this VM powers on this node? What do I want it to be when it's over here on this node? And so you can control those types of things. Now, obviously, you're going to have to worry about dynamic DNS updates and things like that for services that are pointing to this. But at least I can get a VM up and running in my destination easily. OK, let's talk about management and automation. So first, we're going to talk about Server Manager. And then we're going to talk about PowerShell v3. So when I first started, how many people here, when they first started using Server 2012, they weren't that, Server Manager kind of bugged them. They weren't that impressed by it. Be honest, it's OK. Yeah, a fairly good chunk of the room. How many people still feel that way, though? OK. Well, I felt the exact same way at first. I thought, this is kind of, I didn't really like it. And then I started working with it a bit, especially as getting ready for this presentation. And I've actually I've come around. I think there's some really powerful features here. So let's open up Server Manager. Let's go back to the dashboard. So first of all, I can configure which machines I want it to, what machines I want to manage with it. So I can add machines via AD. I'm going to come in here to Tools, Manage, Add Servers. I can select names based off of, AD searches. Sorry, my mouse disappeared for a second. So I can search for machines based off of AD searches and just add them to the computers I'm going to manage with this, whatever the case may be. When I first open it up, I get the dashboard, which gives me kind of a health view. Now, it's full of red because, again, these VMs are always just being powered on and off and whatever the case may be. But I can easily come in here and see, like, oh, my directory services right now, there's something wrong with it. I'm going to go check it out. And surprise, surprise, my little laptop running 5 VMs, including 3 hypervisors, is not performing well right now. So you kind of can get a quick health view of your organization. Now, you might be saying, like, oh, well, I have Ops Manager, or I have SolarWinds, or I have whatever. Yeah, I'm not saying this is enterprise monitoring solution, but if you've got nothing else, this is a great start. We can come down to the local server. This is essentially this screen. I'm sorry. This screen. This screen. Oh, I love when I do this. I give up. This screen where you change your computer name before, it's essentially the same screen. You know what I'm talking about. So, you can change your computer name, look at Windows firewall configurations. Here's where I could enable or disable some NIC teaming, whatever the case may be. And then here's where it gets really powerful, and that's in the all servers category and the ones below it. So in all servers, I can come here. Here's my host 1 computer. I can come here. I can restart the server. I can add roles and features to it really quickly. I can configure NIC teaming remotely. I don't have to RDP to the machine or use my lights out card to get on the machine to do this. I can easily see which roles it has, and it will have the MMCs right here. So if I want to look at DHCP on this box real quick, boom, there I am. I'm in DHCP. I can, and the list goes on and on. If I want to update the cluster, there I go. Pulls me right in there. I don't have to open up Failover Cluster Manager, connect to the right cluster, go to clusterware updating, run the wizard. It's just right there. Pretty powerful. If I want to do a remote PowerShell session, which we'll talk about in a second, here I am. I'm in a remote session right there. I didn't have to, it was all right there at my fingertips. And then below that, it gives me groups based off a role. So if I want to see how my DHCP servers are doing, there they are right there. If I want to come in and look at how my iSCSI servers are doing, boom, there's my iSCSI information. I don't have to, I'm not doing this RDP here, or I need to have this stuff set up here, or, oh, this is easy to do remotely, but this isn't easy to do. It's kind of built from the methodology of, here's Server Manager, do what you need to do within Server Manager. OK? If I want to create a share, I don't have to go figure out, I don't have to go to a specific server to create that share. I just right here, new share. I'm going to do a SMB share quick, select the server I want to create my share on. I don't have to go figure, I don't have to go to a tool for that server to then do that thing. OK, so that's great. That's great if I want to do something once, or it's a one-off, or I'm not familiar with PowerShell. But if I want to do something more than once, that's where PowerShell comes in. How many people here have run the ping command? Come on. Everyone here has run the ping command, right? You are now qualified to work with PowerShell. OK? It's a command line interface. You can do it. And it's gotten a lot better, not only with PowerShell v3, but Server 2012. So let's look at some of the v3 features. So first of all, how many people here, they go to a blog post on how to do something in PowerShell, and the one thing they forget to do is tell you what module you needed to import to run this specific command. And then you pull your hair out for the next 15 minutes, trying to figure it out. So AD, so you look up, how do I look up an AD user? And so you read this blog post. Oh, you do get AD computer, right? Well, so let's look at the modules I have right now. I don't have the AD module imported into my PowerShell window here. So this shouldn't work, right? But it did. So now, when you run a command, it will go and find the module for you and just import it automatically. If I do a get module again here, you'll see that the Active Directory module got added auto-magically. So this is really, really helpful. There's no more of that forgetting to import modules, you type out this big command line and then you forgot the one thing, or it doesn't know the autocomplete stuff because you haven't imported the module. It just figures it out for you now. Let's say I want to get some help on get AD user. So before, you do this get help, get AD user, you're scrolling up, or you're piping it to more. You're like, oh, OK, that's what I need to do. And then you get back to it, and you forget what you're typing, or you're switching back and forth between screens. Kind of painful, right? So now, save yourself the effort. Get AD user, show window. Now this pops up. If I had 2 monitors here, I would slide it over to my second monitor. I've got my help on this screen. I've got my PowerShell window on this screen. Pretty easy to work with, right? How many people here have done a Google or Bing search for a specific commandlet, and they ended up at the TechNet article, as always, right? Well, save yourself the keystrokes. Get help, get AD user, and if my internet connection happens to be working right now, it will take you straight to the TechNet article. Now, the nice thing about going online to get it is that it's up to date. They may have added examples. They may have clarified some stuff. They may have fixed some issues. It looks like my internet connection's working as well as your guys' is right now. So they added a handy update-help. You do update help. It will go out to Microsoft and download the latest versions of the help files on your machine. I'm not going to run it right now because it will never complete, but pretty handy stuff. In Windows Server 2012, PowerShell is now available just about everywhere. You're hard-pressed to find a case where PowerShell will not do something for you. We've already looked at get net adapter. Again, you have to be able to spell it correctly. Get net adapter, you get your network connections. Get net adapter advanced property. Again, you have to type it properly. OK? Get net firewall rule. So, easy to parse information there, obviously. This is Windows Server 2012 is the end to NetSH. I have a friend who's like this networking, one of those annoying networking guys. No offense to anyone here who's a networking guy. But he's one of those guys who's like so far over my head. And he's like, oh, well, no, so there's this one thing you can't do in PowerShell with networking. There's like something that I've never even heard of. So apparently there is some things that you still have to fall back to NetSH for, but they're far and few between. And I know he's working with the product group to get that stuff fixed. How many people here have worked with any type of integrated scripting environment? A few of you. OK. How many people here have worked with Visual Studio? OK. This PowerShell v3's ISE, it's not Visual Studio, but it's getting really close. It's kind of getting to that point where, how Visual Studio, it's just got that IntelliSense magic, and it just makes you really productive. PowerShell ISE out of the box is getting to that, really close to that point. It's a huge step forward. So let's say I want to, I get the color coding. I get the autocomplete stuff. How many people know about the Control-J for the snippets? So those kind of complicated things in PowerShell you can't quite remember how to do, like a do until. How often do you do a do until? Well, now you just pull it out of snippets and you populate it properly. Let's do a quick snippets on for each. So we're going to get all the items in X, which is a collection of processes. And then I'm just going to write verbose X. We'll do description. OK? So I'm going to save this file real quick. I'm going to hit F9 to do a breakpoint. And then if I run in debug mode, I will stop every time I hit this breakpoint. So here I am. I see that I am, I'm working on this X object. Oh, I'm sorry. I completely messed this up. This is supposed to be not X, but item. Yeah. So I hit my breakpoint. And then I can look at other things on the item. I can see the state of my script and figure out what's going on without having to, put in some extra right verboses in there or change my script to get that debugging information I need. How many people have worked with disconnected sessions? All right, cool. Good. One. Few. OK, so in PowerShell v2, we got PS remoting, right? So that's the ability to do run commands on a remote computer via PowerShell. Extremely, extremely powerful feature, right? So here I went over, and I got the name of the computer I just connected to. Or I can create a persistent session to it. So I'm going to, new PS session to demo-san. So I'm going to create this session, and I'm going to enter this PS session. OK, so here I am working away. So let's say it's late in the workday. I'm working away. I decide I'm going to go home, have some dinner, and then get back to this. Today, that means I disconnect from this session, and everything I've been working on is lost. And I got to, anything I saved in a variable or whatnot is gone. With this, in PowerShell v3, we now have disconnected sessions. So that session is saved, and then I can reconnect to it. Think of it very much like RDP session. I can disconnect from an RDP session and reconnect later. So I'm going to store in a variable called x, hello MMS. And we can see that now x stores the variable hello MMS. I'm going to pull out of this session. I'm going to disconnect from it to make my demo work a little better. Session. OK, so I disconnected from that session. Now I'm going to RDP over to a different computer. So you go home, you get on your computer at home, or whatever the case may be, and you can, I always do this, open PowerShell first, get PS session from demo-san. So we can see here in a second, I got my session sitting over there still. So I'm going to grab that guy, enter PS session, enter that specific session again. If I do X, I get hello MMS again. Pretty handy feature. Allows you to disconnect, reconnect from somewhere else, reconnect from the same computer, whatever the case may be. You don't lose all that state that you're working on. So there's a lot more. And I don't have time for, I didn't have time to go through every single possible feature of Windows Server 2012. But there's a few I wanted to highlight. The first is the Enterprise Edition. Enterprise Edition is gone. Remember I was talking about the idea of how much memory can a VM hold? How many people installed Standard Edition thinking, oh, I don't need Enterprise Edition for any reason, then realizing, oh, this machine's got too much physical memory, and yada, yada, yada. Standard and data, now we're down to just Standard and Data Center editions. They're both licensed per processor. Standard license gets 2 virtual machines. Data Center license gets unlimited virtual machines. And that's the only difference between them. So you don't need Enterprise Edition to do failover clustering. There's no feature that Data Center gives you that Standard Edition doesn't. The only difference is, do I want to be licensed for 2 virtual machines or an unlimited number of virtual machines? So the reality is you buy Data Center for your hypervisors, and now you've licensed every Windows VM you have on that machine. Now, besides like the Essentials products, there is one more edition of Server 2012, which is Microsoft Hyper-V Server 2012. This is a free OS that is only the hypervisor. It has live migration. It has storage migration. It has all the features of Hyper-V, but that's the only role it can run is Hyper-V. You could set up a box running the free Microsoft Hyper-V Server 2012, put a bunch of non-Windows OSs on it, and it's completely license-free. You don't have to pay a dime to Microsoft to run that. OK? It can be really interesting for scenarios where you want to set up hypervisors and you don't want people mucking into other things. It just narrows down to exactly what you need. And the list keeps going for the number of things that Server 2012 gives us. Server core versus minimal shell versus GUI mode. So server core is just the command prompt. Minimal shell is just server manager and the MMC tools. GUI mode is the thing that everyone has. The nice thing is now we can move between these with just a reboot. So I can deploy hypervisors with just server core. And then when I run into that really difficult, I'm working with my HBA vendor, and they want me to run some utility that doesn't run in server core, I can just throw on the GUI, the GUI feature set, reboot, and I can now run those tools. So I'm not locked into this core mode. I can get comfortable with it, and I got this backout plan. Domain controller virtualization. So you can now snapshot or clone domain controllers if you're running Hypervisor 2012. Group policy, now you can do a status check to see if your changes to your group policy object have replicated, and you can force policy updates on an OU. You can right-click an OU, say force policy updates, and it will try to force a GPO refresh on all those machines. DHCP, we can finally not have to copy DHCP reservations manually between two DHCP servers. You just right-click and say replicate, and it replicates the changes between them. Kind of, feels like 2003, except 10 years late. iSCSI target. So I can set up a server, maybe running storage spaces, or maybe just for a test environment, and I can have a iSCSI target pointed to it. That's what I'm doing here for my demos. I think where this comes in really handy is a lab environment, or I'm struggling with my production SAN, and I'm not quite sure why. So put up a quick iSCSI target server, point to it. Oh, OK, things are working there right, so I don't have an issue with jumper frames, whatever the case may be. Kind of provides a nice testing environment. And then storage deduplication. So I can dedupe data on my file servers, let's say, and reclaim a bunch of space. I'm sorry, last one, IPAM. So if anyone here doesn't have an IP address management tool, Excel does not count. Look at Server 2012, install the IPAM role. It's a life changer. So this has been Windows Server 2012. Hopefully you've seen kind of how Microsoft, they were running Azure. They needed to step up their OS to be a cloud OS. And all of us are now going to benefit from it, from all these various feature sets. Thanks for coming. You can catch me on my website or on Twitter. I'll be at the virtualization booth on Tuesday and Thursday. Feel free to come by and ask questions. I'll either be up here answering questions or outside for however long. This is your guys' conference. I'm here for you guys, so I'll be here as long as there's questions to answer. Thanks for coming. I really appreciate it. Oh, and one last thing. Please fill out your evals. They're super, super important to all of us. So when you get a chance, fill out your evals, especially if you like this. If not, whatever. Don't bother. But thanks for coming, sir. Seriously, thanks for coming. I really appreciate it.